아, 그 마이크. 좋은 거. 슬랙방에 올렸어. 지금 올릴게. 잠깐만. 관계들을 지금. 예, 재정이가 시작. 내용 토론지만. 아니, 전 안 하려고. 남은 세계를 그냥 뭐 내가 듣고 어차피 두명만 밖에 얘기하는데 안내를 해서 기존의 걸 가져오는 거는 권위를 좀 이용해서 안내만 하고 적용된 게 파이낸스나 나가라고 해야 돼. 내가 새로운 메일을 받아서 새로 만들. 그런 정리가 대화랑 바뀌는 해드리고.
안녕하세요. 이제 그 영어 시험을 시작하기 때문에요. 그 대화하실 거면 나가셔서 대화를 해주시면 되고요. 아니면 그 관련을 하실 거면 잠시만 조용해 주시기 바랍니다. 네, 1분 있다 시작합니다.
$135. 135분? 4시 10분? 4시 10분까지 가면 돼요? 아니면 네, 자체적으로 4시 시간을 연장한 거예요? 아니면 10분까지 예, 알겠습니다. 허락 받는 맥스 20분까지 그 사이에 우리 집 되고 있을 거예요. 네네. 이렇게 10분
제가
이 정도 그냥 시작해. 시작. 지금 그 슬라이드 올렸어.
Alright, thank you for coming for the BOScoin live demo. A lot of people came here for the initial talk, and this is basically the second part, which is for the global live audience. And we're going to do a quick run through of some of the features, especially focusing on the trust contracts in the next session. Right, so BOScoin is a self-evolving cryptocurrency platform built on trust contracts, and I'll explain what exactly these words mean in a moment. So this demo may actually be focused slightly more towards developers, but I'll try my best to explain each of the concepts one by one. Right, to give you a bit of background, why exactly did we create BOScoin? Well, our team, we're actually huge fans of Bitcoin and Ethereum. We believe in the vision of transparent and decentralized systems, and we believe that smart contracts, programmable finance, and cryptocurrencies can hugely benefit society, which is why we started on our version of smart contracts. We call them trust contracts. However, we believe that there are still issues that need to be solved. The first is change. Software needs to be consistently updated and managed. There can be bugs built into the software, like the overflow bug in Bitcoin, and external factors are always going to be changing. Software needs to adapt. This is why we believe that there should be a systematic way to implement change in a decentralized system. The BOScoin team aims to solve these issues with an embedded governance system. The second issue is security. Last year, $50 million worth of tokens were stolen from the DAO app. Smart contracts are basically programs that deal with money. The first and foremost focus for smart contracts should be security. How can we keep the network and users safe? So we did a lot of research into how banks operate with their money, how banks use their money, and the outcome, our answer, was trust contracts. Of course, we want to explain both of these concepts in depth, but today we're just going to focus on the latter, trust contracts. So what a trust contract is, how does it work, and how do you build one? Right? We still have quite a lot of development to do, but you can follow our demo as well as the project by cloning the Git repository. So these are a couple of lines to get you started. There's a couple of packages that may not be installed on your computer. And if you write down the following commands, you can follow along with the demo as well. All right, so we'll jump right in. First, I'm going to download the owl chain core from GitHub. Right, so I'm plugging the owl chain core into my file system. And at the moment, the file is not that big, so it shouldn't take that long. Yeah, it's 100% done. I want to show you a little bit about how the project is structured. And this owl chain here is basically what we downloaded. As you can see, there's dependencies, documents, and sources. And to see some of the packages and dependencies that we've used, they're actually listed inside this small file here, the dub.stl. We're using a web application framework built by D. It's called the D framework, and it's a pretty fast and light web application framework. That's why we're using it. Some of the other libraries and dependencies are message packs, as well as a cryptography library called Sodium. So you can see that here. And then there's also a package called SDLang. Now, SDLang is basically the language and the semantics that you're going to use when building trust contracts. Yeah. We get a lot of questions on why we're using this particular language, D. But first of all, our developers like it, and that's why we're using it. And secondly, it also has a lot of performance. It has a lot of performance perks, basically. You have the ability to use operating system APIs as well as use the hardware as well from the computer language. And additionally, it's also quite efficient to use. So productivity-wise, it also has a lot of perks that our developers enjoy using. Right. So now I'm going to start building it. All right, and now from the DUB repository, we're basically updating all the different dependencies automatically. Yeah, so this is just going to take a moment. And when this is finished, we'll be able to see the web application on the web browser. Alright, now it's been compiled and built, and as you can see, we can see it from the local host on the port 8080 in our browser. Alright, so this is basically a simple page where you can test and build trust contracts. And I want to explain to you just briefly the architecture of what exactly we're talking about today. So the whole project obviously encompasses everything from the writing of the contracts to the blockchain, but today we're only going to be focusing on this aspect here, the trust contract aspect. Now, what the users of trust contracts will have to do is they'll be using the STL code, which consists of the OWL language and the TAL language, so the web ontology language and the time automatic language. And what users can do with the STL code is basically create rules, business rules. And obviously putting business rules on the blockchain is basically the goal of what we're trying to do. Secondly, if you expand those rules, you can create decentralized applications, which is what we're aiming for, just like Ethereum. Additionally, what we have is a set of ontologies. So this is basically a library that we brought in from the internet that's been developed for over the past 10 years. Ontologies have been used in lots of different kinds of domains, especially finance and medicine. And what we're doing is basically we're using that ontology and bringing that into the blockchain so people can use these ontologies that have been already developed. After writing the code, you have to interpret it, right? You need to process this kind of code. And as some of you may know, OWL and TAL is actually one part is data and one part is logic. OWL is the data part and TAL is the logic part. And you can think of it kind of similar to web technologies. So HTML and JavaScript also deliberately divided the data and the logic aspect of the programming in order to clarify, I guess, the development process. And that's exactly what we did. We have OWL to describe the data and TAL to describe the logic. We're actually, this is a bit more nuanced, but the data aspect of our programming language is much more intelligent than an average HTML system. What we want to do is we want to increase the focus on the data and decrease the focus on the logic, which is considered a lot more difficult from a programmer's perspective. Right? And with the data, what we do, we process the data with a reasoner, we process the logic with an interpreter, and these two features are basically inside the inference engine. And what the inference engine does is not only does it upload it to the blockchain, it also pre-audits the code. So it sees whether there's any systematic errors, it sees whether there's any semantic errors and logical errors. And that's one of the key features of this OWL and TAL architecture. We check the code to see whether there's any errors before it's uploaded onto the blockchain and can cause any harm. All right, so let's go on and I'll show you a couple of examples of what an ontology actually looks like. So this here, let me just expand it a bit. So this is the ontology of a coin. Obviously, it might not be very familiar, so it might not look very easy to a lot of people. But it's a very common structure that people use in web ontological semantics. And so you can see that these are the ontologies that we're importing. As I said before, there's a lot of ontologies that have been already built and have been used in business environments. And you can see these ontologies straight on the web, even at this point in time right now. So I'll show you how these are actually defined. And as you can see, there's a whole list of different types of objects, properties, and relationships that are defined within the W3 organization. And we're using all this this knowledge that has already been used and tested on the internet. And what we're doing is we're borrowing this set of data, and then we're adding a bit of ours, the coin ontology, and creating a new ontology to build coins. So this is all the information that you need to build another coin by yourself. And so the example that I want to go through today is basically the decentralized Airbnb. So we thought about the question. I thought, what are the pieces that you need to create a decentralized Airbnb? So obviously you need a currency to pay for the real estate. And then you need an account. So you can't just have money. You need to have an actual account where you can store the money and send the money. And then thirdly, you'll need the real estate contract. So as the name trust contract states, what we're trying to do is we're trying to get real-world contracts onto the internet, onto the blockchain. And so as long as we have these three things, a coin, an account, and a real estate contract, we should be able to create our very own decentralized Airbnb. So let's go through some of the steps. So we're going to start with the Hello World coin. Right. Now, because we've imported this ontology, basically all the information that I just showed you is already inside this contract. All the relationships between the different parts, the objects and the properties are already defined. All you really need to do is to create a coin, is to input a couple of fields, like the name. The name is Hello World coin. The minimum value, which is 0.0441. The symbol, and the total supply, which I think is 10 million coins. Right? And there's another piece of information here. And this just basically states that the Hello World coin is a subclass of another coin, of coins in general. So now that we've defined all the different parameters that need to be used to create a coin, we submit it. Now this isn't going up directly onto the blockchain yet. What we're doing now is we're basically defining, we're basically checking the syntax and the semantics of the coin. Yeah. So basically we're going OK. So now we know that this contract doesn't have any issues with it. And then we can also see a visualization. So you see, this is quite a simple ontology, so there's only 2 pieces. But you can see that this whole hello world coin is a subclass of a greater, a more higher concept, which is coin. And then we'll go on to confirm. And what this does is it creates a transaction, and now, theoretically, it's uploaded onto the blockchain. Right now, it's not actually uploaded onto the blockchain. It's just a demo, so we're just showing how the contract works. The part about the demo, I'll explain it. The part about uploading onto the blockchain, I'll explain at the very end. So we can check that this address is saved in our contract. So you can see that the hello world coin was created. And then we're going to go on to create an account. Now this is a slightly different type of trust contract. What you're doing is we're not creating an actual ontology. We're actually creating an individual instance of the coin. So basically we're creating an account within this ontology. And again, you only need to input the types of data that we're using. So again, we're using the coin data, and we're going to charge an amount of 100,000 hello world coins into this particular account. And again, this is our address with 100,000 hello world coins. Now that we have money, what we can do is we can create the real estate contract, which is slightly more complex. But it's basically the same. The real estate contract is basically divided up into 3 different parts. There's a DC, the person who's borrowing the property, and it has the individual property values inputted, so what the phone number is and what the registration numbers are. And then there's the leaseor, the person that's actually borrowing, that's putting the property out. And then there's the property itself. These are the 3 different types of classes that are used inside the real estate contract. There's the DC, the leaseor, and the real estate itself. And what we're doing is we're combining these 3 classes, and then the information we got in the actual contract is referred to down here. And the most important part, I guess, is money. Okay? How much is the deposit? This is the amount of money that we're going to be sending with Hello World coins. So let's save that. And again, we'll go through the same process. We'll submit it. Oh, there's an error. Got the title. And as you can see, there's no errors now. And we basically created the trust contract and put it up onto the blockchain. And now that we have all the 3 parts, we have a coin, we have an account, and we have a real estate contract, what we're going to do is we're going to send the money from the account to the real estate contract. I'm just going to use this template that's conveniently provided for me on the website. And I'm going to send the amount that I have from my account to this particular transaction, to this particular trust contract. All right. There's not enough balance actually. I think I sent a bit too much, so I'll just reduce this to about 70,000. And it's, sorry, that's 7,000. And I'm going to try running it again. And if you remember, the deposit is actually 50,000. And if I try to send 70,000, the properties and the conditions are already defined inside the our ontology. And that's why there's already an error. And so from a consumer's perspective, or from a person that has to sign a contract, they don't actually have to know about the procedural logic that goes on behind the scenes. All you have to know is that what was declared, what the conditions are, and input the amount that the conditions state. So now let's put in the correct amount. 50,000 Hello World coins. Yeah. Then as you can see, the transaction was a success. 50,000 were sent to this particular trust contract, and my balance should be 0. I tried running that again, and it says that the deposit has already been sent. So that was the whole cycle of how a trust contract or a decentralized Airbnb would work. All you need are these 3 parts: the coin, the account, and the real estate contract. And obviously, you can try this in your own local environment as well. So yeah, so watch out, Airbnb. We're going to decentralize you.
Watch out.
All right, so how does this all fit together? I told you the blockchain aspect of things, we're still working. The M0 demo day, which is today, we're just focusing on the trust contract concept today. Next week, we're going to have a BOScoin fundraising event. And then during the testnet or the alphanet in July, that's when you'll actually get to start using trust contracts and remittances on the consensus algorithm FBA. And you'll also be able to play around with the inference engine a bit as well. But the real interesting project starts in October. That's when the LiveNet will go live, and it's also called the Genesis block. So during the Genesis block, you'll be able to use simple trust contracts with the inference engine, and we'll also be supplying the blockchain explorer. In M3 and M4, we'll be developing the proposal and voting process, and then the self-evolving aspect, so the automated proposal and voting aspect, will be applied in M4. All right. Thank you everyone for joining the demo day today, and hopefully I'll see you afterwards or in our Slack rooms. Thank you very much.